What we can do, though, is we can have checks at each stage. When the data is ready to be curated, we want to ensure that it's well distributed and the annotations are good. When the model is trained, we want to check the performance on each frame, and we can also look at series of frames to help us understand the robustness. And when the robot is tested, we have to look at why performance changed. Was it across the board, a specific area? How much did the robot software change in this time? So if our data is bad, like everything else is downhill. In this sense, what we actually have to measure is not really what's in our data set, but how changes in our data set affect robot behavior.
We actually found that our performance on the horses drastically differed based off of the season and the lighting conditions. So we measured how well we were doing and realized, oh, we need to take another big swath of data and go train things again. Borderline images, things that don't have the highest confidence, you can send those for training. Ones that you're very confident on, you're already doing well. Once you've set up your model in production, make sure you measure how confident you are with each of your predictions.
So the best solution, though, is really to use models to flag low confidence annotations. These can find both one-off issues and systemic issues. So I was not asked to say this, and I think I probably was asked not to say this, but I do want to say that last week we used Hasty to sort of check our model, and it brought to light this really interesting issue that there was inconsistency in whether items were labeled individually or as a group, and this was causing low model confidence. So this week, that's what the annotators are fixing. So it was a pretty exciting discovery.
Soon, there is the concept where we might have a feedback system where the client can either correct us or even just say if it was good or bad, and we can use that to feed things back.
And then as the robot developed from a mule to a prototype, the robot kept changing. So the camera type changed, the camera angle changed, the lighting exposure changed. And the less the training data is like the real data, the poorer the model is going to perform. So with each step forward of the robot, it's like we take the step backwards for data.